Okay, this video is for the homework, just as extra examples. Your homework looks similar to this, so this will help you complete that. Hopefully I can get through it without coughing today. So you want to draw a sketch of the normal distribution and shade the indicated area. Then you can use your chart, you can use normal CDF on the calculator, or inverse norm to find the given values. So we want the probability that z is less than 2.06. So if we graph this one, or draw the chart, there's your normal curve. 2.06 is up here to the right, because remember 0 is always in the middle, so 2.06 is there somewhere. And we want less than, so that's the probability to, or the area to the left. So I'm just going to use the chart for this. So if I use the chart, go to 2.06 on my chart that's posted. So I go to 2, which is here, over to 0.06. We should be at 0.9803. You can use normal CDF on the calculator if you would prefer, but most people think the chart's easier. Probability that z is less than negative 0.147. So negative 0.147 is going to be over here. Less than's to the left. So again, I'm just going to use my chart, use the negative page, go to negative 1.4, which is here, and go over to 0.07, which is here at 0.0708. If you do decide to use the calculator, the normal CDF, you have to do normal CDF, second var is normal CDF, and then lower bound, comma, upper bound, comma, mean, comma, standard deviation. And when we're talking about z-scores, the standard normal, your mean is 0, standard deviation is always 1. But like I said, I think the chart's simpler than trying to remember that. The probability that z is greater than 1.03, and then when you draw these, they don't have to be perfect. Mine never are. I can't draw that well. So 1.03 would be about right there. Greater than means to the right. So the probability, you have to remember the chart gives you the area to the left. So when you do the probability, it gives you this over here, and the area under the whole curve is 1. So you have to do 1 minus whatever the chart tells you. So 1.03, if I go to 1, which is here, over to 0.03, 0.8485. So I'd have 1 minus 0.8485, which is 0.1515. The calculator, you don't have to subtract, because you could do the lower bound, which would be 1.03, and then the upper bound of 1,000 or 10,000. So the calculator doesn't care, but most people prefer the chart on this, so you just have to remember to take it away from 1 when you're doing to the right. Probability that z is greater than negative 3.06. So negative 3.06 would be way down here. Greater than is to the right still. And it's to the right, so we still have to take it away from 1. So we have to do 1 minus the value for negative 3.06. Up here is negative 3. Go over to 0.06, you're at 0.0011. And if you subtract, you should get 0.9989. For number 5, you have between two z values, so you've got between negative 1.65 and 2.31. So it's negative 1.65 and 2.31 here. So you have to remember, so if you use the calculator on this one, you would do negative normal CDF, negative 1.65, comma 2.31, comma 0, comma 1. It'll do it, that's fine. If you still want to use the chart, remember the chart tells you the area to the left, so if we look up the value at 2.31, we'll have all of this to the left. So whatever that value is, we need to take off the value to the left of negative 1.65, and that'll leave you with what's in the middle. So if you go to 2.31 on the chart, you have 2.31 is 0.9896. Like I said, that's all of this, and then we want to subtract off whatever this little piece is, so to the left of negative 1.65. So if you look at negative 1.65, go over to 0.05, you're at 0.0495. And if you subtract, you get 0.9401. For number 6, it is also between two z-values. You've got between 0.52, which is kind of close to 0, so almost in the middle there, and 3.24, which is up here, and you want the area between. Same thing, we take the area to the left of 3.24. So if you look at your positive side and do 3.24, 3.24 is 0.9944, and then we're going to subtract off 0.9994. I think I said that wrong. Subtract off the area to the left of here, the area to the left of 0.52. So we go to 0.5 and over to 0.2, 0.6985. And that leaves us with the area between. So that would be equal to 0.3009. And remember, if it just says probability, you can leave the decimals. If it says percentages, you move the decimal place to the right. So that's the first 6. For number 7, this is going the other way. So it wants you to find the z-score such that 35% of the area lies to the left of the z-score. So remember, at 0, it's 50 and 50, so 35% to the left will be over here somewhere. So that's 35%. So this is when the calculator is probably easier, because you have to go through and try to find 0.35 or something close to it on the chart. So this is when you can probably use inverse norm a little bit easier. So if you go to the calculator and go to second vars, and you have to remember that you always put in the area to the left, so second vars, and choose number 3, and then type in 0.35, because that is to the left, you get negative 0.39. Remember, probabilities are rounded to 4 decimals, these scores are rounded to 2 decimals. And you can kind of check that if you look on the chart at negative 0.39. Here's negative 0.3. All the way over, it's 0.3483, so that's close to 35%. The problem is if you don't do it on the calculator, you might debate between if you should use negative 0.38 or negative 0.39, because they're both round to 0.35. So that's why I would say to do inverse norm on the calculator. Find the z-score such that 28% is to the right. So that 28% is to the right. Remember, when you do inverse norm, it has to be the area to the left. So if you have the area to the right, to find the area to the left, you just subtract it from 1. So 1 minus 0.28 if we switch to decimals. Or you could, if you know, because if this is 28%, this would be 72%, so you could just type in 0.72 instead. Either one. So go to second vars, choose number 3 still, and then 1 minus 0.28, or you can type in 0.72. And you should get 0.58. And then the last one on this page, find the z-score such that 60% lies between the two values. I'll hold my paper for down here. That one was kind of ugly, but So if you want between two z values, remember it's symmetric, so this will be negative z and this will be positive z. And if you're between two z values, this curve's really not pretty, but that's okay. You need to know the area to the left. So if 60% is here, that means you've got 40% left, and the whole curve adds up to 1 or 100%. So we would have 20% here and 20% here. Because it's supposed to be symmetric. I know my picture doesn't look it, but it'll be okay. It is symmetric, so if there's 60% in the middle, you have 40% left over, so half would be here and half would be there, so 20 and 20. So you can also do that if you'd say 1 minus 0.6 gives us 0.4, and then divide 0.4 by 2, which gives us 0.2, which is 20%. So we type in the area to the left, so it's going to give us the negative z first, and then we're just going to use the positive one too because it is symmetric. So we'll do the inverse norm of negative 0.2, of 0.2, not negative, sorry. Inverse norm of 0.2, and that's going to give us, if I could hit it, negative 0.84. So this one down here is negative 0.84, which means since they're symmetric, this one's up here is positive 0.84. So z is plus or minus 0.84. So if you want the z-score when you're between two values, just remember subtract whatever's in the middle from 1, divide it in half, and then you can use inverse norm. So that's the first page, and then the second page, instead of just giving you the z, it deals with your raw score, your x values. So it's the same thing except you have to find z first. So it says draw a sketch, shade, and then you can use normal CDF or inverse norm or chart. I didn't put chart up here, but you can also use chart. For problems 10 through 14, you assume 27 is the mean, standard deviation 6, and it tells you these are multiple step problems. So the probability that x is less than 25. So first step is we find z, because you would probably want to use the chart. You can do these on the calculator without finding z, but it's easier just to calculate z. So we're going to use the formula z is equal to x minus mu divided by sigma. And it tells us our mean and our standard deviation there. So z is equal to x, which is 25, minus the mean of 27, divided by the standard deviation of 6, which is equal to negative 0.33. So if you draw this, negative 0.33 is here, and it's to the left. It's the corresponding to 25, is what it corresponds to. So the probability that x is less than 25 is the same as z being less than negative 0.33. And you can use your chart again, negative 0.3 over to 3, 0.03, 0.3707. For the probability of x being bigger than 31, still calculate z. So we're going to do x is 31 minus the same mean and the same standard deviation. This one gives you 0.67. And this time if it's greater than, we're talking about the area to the right. So here's 0.67 and this is the area to the right. Corresponds to 31 if you use x's. So the probability that x is greater than 31 is the same as the probability that z is greater than 0.67. So again, if you're doing the area to the right, you have to remember to subtract it from 1. So we'll do 1 minus 0.6, the value for 0.67. So there's 0.6 over to 0.07 is 0.7486. And that gives you 0.2514. And again, this says probability. If it said percent, you could switch. The probability that x is greater than 44. Calculate z using this x. So 44 minus same mean, same standard deviation. We get 2.83. So 2.83 is somewhere in there. So the probability that x is greater than 44 is the same as z being greater than 2.83. Again, it's greater than, so you got to remember to subtract it from 1. So 1 minus 2.83, here's 2.8 over to 0.03, or 0.9977. Which is equal to 0.0023. So if it gives you the x value, calculate z first using that formula, and then just do it like we were just doing on the first page. Find the raw score such that 15% of the area under the standard normal lies to the right of that value. So this one wants you to find the raw value. So instead of finding probability, you want to find the raw score. So you have to calculate z first. So 15% lies to the right, it says. So that will be 15% here. So if there's 15% to the right, that means there's 85% to the left. So to find z, you do the inverse norm of the area to the left, which is 0.85, or 1 minus 0.15, however you want to type it in. So we're going to do second vars inverse norm of 0.85. We get 1.04. Remember, z always round to 4, round to 2, probability round to 4. And that's your z value, but it doesn't say find the z score. It says find the raw score. So we actually want to find x. So our x formula, if you solve this, is z times sigma plus mu. So we're going to do x is equal to 1.04 for z times sigma, it's still the same sigma, 6, plus mu, still the same 27, using that same mean and standard deviation for all these. And you should get 33.24 minutes in this case. Find the raw score such that 13% lies to the left of that value. So this time, oh, well, that was really bad. I'm trying to hold the paper and hold the recorder. Try to do it this way. Okay. So there's your normal curve. 13% lies to the left. So for z, we're just going to do the inverse norm of 0.13 because that is to the left. So if you do inverse norm, if you already have it up there, you can hit second enter. And it'll pop up, and then you can just go over and type 0.13 instead of 0.85. That gives us negative 1.13. And then that's our z. We want our raw score, which is x, so we do negative 1.13 times standard deviation, still 6, plus mean is still 27, and that gives us 20.22 minutes. So that's all the video for the explanations on that one. So this should help you do the homework for this week. If you have any questions, please just let me know.